part two of our look at cloud storage, I'm going to be talking about various things like databases, file systems, and I'm going to also talk about some of the other cloud platforms besides AWS. Our first look is at databases. Obviously, everyone knows about the uses of database management systems, how they allow you to query and analyze data. They can scale to fairly large sizes. There's validation formats. You can have concurrent accesses. There's all sorts of good things that you can get in databases. There's also different types of databases. We have relational databases, which most people are very familiar with. Very popular addition to the SQL-based databases are the NoSQL databases. And on top of some of the NoSQL databases, you also have what is now becoming very popular in the linked data community called graph databases. So you have these choices, and almost all of the large platforms will provide you with many choices within these categories. Relation databases are obviously useful when you want to do a large number of searches or joins or some complex operations on your data. Its big advantage is that there's a standard relational algebra language called SQL that facilitates you being able to search and to do various mathematical operations on the data. If you are just looking at some of the very popular, not very scalable databases like MySQL or Postgres, they're available in cloud-hosted forms. They have, they're actually very good databases. They scale up to a certain size. They're not the largest, but for most applications, they'll be adequate. You also can spin up an instance of a VM, which we'll talk about later in the course, and you could run your own database system. So you're not, you don't have to take their version of MySQL or Postgres, but they obviously, there's advantages to using their versions. They set it up, you can use it. The other big advantage that cloud vendors will provide is that they have specialized, optimized relational databases that can scale to particularly large data sizes, and they offer performance in the way that MySQL or Postgres can't offer, but that it comes at a large price. Now, one of the advantages of going to a relational database is that it supports ACID semantics. So ACID stands for atomicity, so the idea that when you're doing transactions, so all of this is transaction based, so either the transaction succeeds or it fails, and it does that in its entirety. There's no partial success or partial failure. There's consistency. The data collection, your database, is never left in an invalid or conflicting state. There's all sorts of checks and balances to make sure that any of your transactions that go in will leave it consistent. There's isolation in that you can do concurrent transactions and they won't interfere with each other. And there's durability. Once a transaction completes, system failures can't invalidate the result, which means that you know from your system logs what's in the system, what isn't. But obviously, with any failure state, if a transaction didn't complete, then you don't have any guarantee about the state that the database is in. But there are tools for managing relational databases so that all of the ACID characteristics are there. Now, we're going to look at NoSQL databases because they have different characteristics, and some of them will not give you full ACID semantics. So what's the motivation? Well, the biggest motivation is the quantity of data. If you're looking at the standard type SQL databases, a lot of them have trouble when you either get a large number of users or a large quantity of data. And so you want to be able to scale to large sizes. The other thing is that there's some data that doesn't really fit the tabular form that relational databases demand. And so if you have data that fits very nicely into a table, then you're looking at a relational database. But if not, then the NoSQL databases are far more effective for you than trying to shoehorn this unstructured data into a tabular form. So the NoSQL database is based on a key value system. So it's a key value store. It will organize large number of records. So what it does is each of the records is associating an arbitrary key with an arbitrary value. So you have this key value pair. And then often what's put on top of this is a facility to do a text search. If it's called a document store, it will actually provide text searches on the stored value. So you can retrieve by key or by searching through values. The NoSQL databases that you do often have from a cloud provider are distributed over multiple servers. Their structure allows them to easily be replicated over multiple servers in different data centers. Now, the problem with this is that they don't always satisfy all of the asset properties. And usually the one that it's not satisfying is consistency. So this is usually replaced with eventual consistency, meaning the database the state of it may be momentarily inconsistent across replicants. And so if you have the replicas in different places, if you have a problem in updating all of them, you may have some inconsistency, but it often isn't for very long. Now, one of the things that is interesting, and one of the authors from the online textbook that I've suggested is one of the people who has looked into this theorem, which is called the CAP theorem. And this is looking at C standing for consistency, so that everybody sees the same data at the same time. Availability, which means that every request will receive a response, but whether it's failed or it's succeeded. And partition tolerance. So the system continues to operate even if there's a network failure that doesn't allow computers to communicate with each other. So one of the problems with having a distributed system and spreading your database across this is that the system itself usually cannot maintain all three of these properties at the same time. You're usually going to give up something. So when you're designing a database management system, the designer usually has to choose between high consistency or high availability. If you're interested more in about how large scale databases are designed, or large data systems designed, I've given you a reference to a book that it has very interesting articles that are discussing this CAP theorem about how you can get either very high consistency or high availability, but can't get both. So cloud systems, they are going to have this problem that they are distributed systems, and that means when you're designing your database, you have to take all of that into account if you're going to design a very large and redundant system. So if we look at this summary that's in the online textbook, you can look at storage as having these different facets. So you can go all the way from files, which you can get in file systems that look very much like the file systems that you're used to. All of the, I've given the Amazon, Google, and Azure columns here for what the different services are. We'll be looking at some of these. You have the object systems, so you can go from a file system that you're very familiar with to object stores. We're going to be looking in detail at the simple storage system next week, and then in future weeks we're going to be looking at the blob storage system on Azure. You can get relational databases. There's, like I said, there's the standard ones like MySQL and Postgres, but you can also get different services like Aurora, which are very high performance databases, but they're also very pricey. In the NoSQL world, we're going to actually in this course look at DynamoDB from AWS, but all of the major systems have some form of NoSQL database. There's graph databases. Some of them are actually very high performance that you can get on the different systems, and there's more than just the ones listed. And then you have like the data warehouses where you have the systems for providing huge amounts of storage and manipulation of that storage. If we go on to just briefly going over all of those different manifestations of storage that we can get in the cloud. The first thing that we've talked about before is file systems. And I'm just going to go briefly over what you get with Amazon. With Amazon, you can get elastic block storage or elastic file systems. And these are services that you're going to get when you mount one of their VMs, which they call EC2. And this gives you low latency access to data from a single EC2 instance or from a single VM. So with these systems, they're going to come from, you have to instantiate a VM and then work with that, and it has an associated file system. So the elastic file system's general purpose file storage, it has a file system interface, access semantics, and you can get concurrently accessible storage for many EC2 instances from Amazon. But the thing about the elastic file systems and elastic storage on Amazon is that you can only access this from inside the Amazon cloud. So in other words, multiple EC2 instances or VMs can speak to that file system, can be attached to that file system, but you can't attach anything outside of the AWS universe. And we'll see this is a little bit different when we look at how Azure does it. Now, one of the things that you're going to be working on first for the first assignment is the Simple Storage Service, S3. And in fact, it's so ubiquitous now, saying S3, it really now just means it's a type of service, even though Amazon uses that as the name for the service. But now everybody uses that as a name for an object store. It was its first cloud service, and it's still well used. Reportedly, by 2016, there were trillions of objects in billions of containers or buckets, as they call it. And it's a classic object store. There's nothing fancy about it. Other services also have object stores. This was the first, and this is still the most popular. With AWS NoSQL storage, we're going to be looking at Dynamo. It's a fully managed service based on key value pairs. It requires only a primary key, and you don't have to have a schema to create a table or sort of a table. It's not the table in the traditional relational database sense, but it is a fully functional, fully managed NoSQL service. With Dynamo, you get a lot of different services or characteristics, and some of these are not the same when you look at, when you compare them to other NoSQL databases in different cloud providers. So you have on-demand capacity mode, which means you can scale up and down. This is obviously a feature that almost all cloud systems want to provide, because the idea is that you can scale anything you have according to accommodate the traffic you have. And obviously the money you have, because you have to pay for scaling up. But you can scale down to save money. It has built-in support for ACID transactions. So you actually have support for transactions in the traditional sense of what you get with a relational database. And it has on-demand backup. So you can have a complete backup of your work at any point of time. You can ask for it to be backed up. Also, you can get point-in-time recovery, which means that if you have an accidental read or write operation, you can back it out and recover. And you can have your data encrypted when it's not in use, which is a nice feature for a lot of systems. So you can, it has the encryption feature as part of DynamoDB. It has three fundamental units. It has a table, which is a group of items. It has an attribute, which is a single field or piece of information that's attached to an item. And an item is a set of attributes. The NoSQL part has to do with the keys. So DynamoDB has a primary key, which is a unique attribute. It's necessary for creating the table, can't be null at any point. All of the items in your table have to have a unique primary key. So a simple version of this is called the partition key. It's a single attribute, and this is it has to uniquely distinguish items in the table. You can also compose the primary key, the partition key, with a secondary component called the sort key. So you can have two items put together to form this larger notion of a key. And also, DynamoDB will allow you to create secondary indices, which means that you can basically query the data without looking at the primary key. You can also, you don't have to set up secondary indices. You can just do a search over all of the items in the table. But obviously, the more you put into indices, the faster, the more performance you're going to get out of your queries. So that's a very quick look at the sort of the basic selection for data storage for the AWS universe. But we have two other large cloud providers out there, Azure from Microsoft and the Google Cloud Platform, obviously from Google. So let's first look at Azure. It provides file systems. The difference here is that you can create a file system and it can be accessed with a special protocol, the SMB. And what's really neat about that is that it allows Windows VMs and Linux VMs to mount these file shares as a part of their file system. And you can do this in the Microsoft Azure cloud or outside of the Azure cloud. This is a nice feature that isn't available in AWS. So this is a distinguishing feature that you can actually share the file systems between multiple VMs within and outside of the Azure universe. Azure also has an object store. It calls this their blob storage service. So once again, it's looking at unstructured objects or blobs. It's very, very similar to S3. The only thing that's a little bit different in a way is that they have a tiered storage system, which really has much more to do with what you're going to pay based on what kind of performance you want when you access the data. So there's what they call hot, if you have frequently accessed data, or cool for data that's not accessed as often. And obviously, you're going to pay more for the hot. I've got a link here to some information about Azure storage. But don't worry, we're going to be coming back to this in a few weeks where we'll actually be doing some work on Azure. You're going to have to get an account, and you're going to be doing a little bit of an assignment is going to be on Azure, and it'll probably have some things to do with their blobs and some other nice things with Azure. The next system is that of the popular cloud platforms is a Google Cloud Platform, or GCP. And it has what it terms persistent disk storage. So with this, I mean, with all of these systems, they're giving you the same thing. But with they call them things slightly different in all of them. But with the persistent disk, they basically give you a network storage device that your instance can access, just like your file system access disks on your laptop or on a server. The data can be distributed actually across several physical drives. It's different it's slightly different from what you get with AWS in that these disks are located independent of your VM. So With AWS, it's the most closely tied when you look at file systems to their VM system. Although you can ask when you set up the system that the file system doesn't disappear when you delete the VM. But with the Google storage system, what you're talking about is that you have these persistent disks so that your data can stay there even after the instance goes away and different instances can connect to it. Google also has its own bucket system, so it has storage buckets. This gives you a lot of flexibility with what you're doing. Obviously, it's an object store. You don't have the same constraints as you do with a file system. We've got, I mean, this is the usual thing that we see. You can mount a cloud storage bucket to a VM. Once again, this is different. And you can use it as a file system using the Cloud Storage Fuse tool. It can't be used as a boot disk, but it can actually function as a file system. Once again, distinguishing Google's object store from AWS and from Azure. So you're going to get used to using the storage system, particularly with AWS, but you also are going to have some experience with the other two systems as well.